Hello water managers, my name is Kat Feingold, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be covering an overview of the Russian River watershed. This watershed is used in the SWMS Prospect class workshops. The overview is meant to give water managers completing the workshops a general understanding of the watershed in order to be able to better answer the questions and complete the tasks in the workshops. There'll be a link below this video to the workshops themselves. In this overview, we're going to go ahead and cover the watershed itself, including its geography, land use, and hydraulic structures. We'll touch a little bit on the climatology that drives the area, and then we'll take a look at some of the real-time data sources available on the Russian River watershed. The Russian River watershed is located in Northern California on the coast. The river starts as two forks, one in the east and one in the west, which join downstream of Lake Mendocino. The river runs directly south for most of its course before heading to the west coast directly before it reaches Santa Rosa. Major tributaries are listed at the bottom. They are listed from north to south. So the watershed itself encompasses a total of just under 1,500 square miles. And from top to bottom, it's about 100 miles long. At its widest point, it measures 32 miles, and at its thinnest point, 12 miles. There are some major dams and diversions along the river as well. The first is Coyote Valley Dam, located at point A here, which is on the eastern fork of the Russian River at Lake Mendocino. This is just upstream of its confluence with the western fork. The dam itself is 160 feet tall and 3,500 feet long. It is an earth-fill dam, and it began operation in January of 1959. So the gross pool storage is about 122,000 acre feet, although about 50,000 acre feet of the storage is maintained for flood control during the winter months. So it is a multi-purpose dam, and it's operated for flood control, water supply, irrigation, hydropower, and recreation. So Warm Springs Dam at point B is located on Lake Sonoma, where the confluence of Warm Springs Creek and Dry Creek, about 14 miles above Dry Creek's confluence with the Russian River. Construction of this dam began in 1970, but it wasn't in operation until 1982. So this dam is 319 feet tall and 3,000 feet long, and it is a rolled earth embankment. The gross pool storage there is 381,000 acre feet. It is also a multi-purpose dam, and it's operated for flood control, water supply, and recreation. Next, we have the Potter Valley Project up here at point C. So the Potter Valley Project is an interbasin water transfer from the main stem of the Eel River. Historically, the Potter Valley Project supplied about 159,000 acre feet annually to the Russian River. However, after a FERC relicensing of the L River dams, it is only required to provide 90,000 acre feet and is one of the driving forces behind FIRO in that area. And finally, we have the Sonoma County Water Agency, which operates a temporary inflatable dam and infiltration ponds. This is primarily used as groundwater recharge project. That brings us to the land use. So the economic output of the area is predominantly agriculture, to include wine grapes, pears, apples, field crops, sheep, cattle, and poultry. So you'll notice from the key here that most of the area is actually predominantly forest, especially in the northern areas. Agricultural and rangeland is interwoven throughout the entire watershed, and its population, which has grown from around 65,000 in the 1950s to over 400,000 people today, is primarily located in its southern end. That's also where you see a lot of flooding. Channel capacities in the area are very diverse. So in the broad valleys of the watershed, they're relatively low and prone to flooding, but increase in the deeper canyon areas. So bankful capacities in Ukiah area between 7,000 and 8,000 CFS, and that's also the same in around the Hopland area. However, as you move further south in the Alexander Valley and near Garnerville, you get closer to 20,000 and 35,000 CFS bankful conditions. There are 18 permanent bridges on the main stem of the river, and they're mostly located near large cities and towns. Severe floods can overtop bridges, especially near Hopland and Garnerville. And it is worth noting that we'll talk about it later. However, Garnerville tends to occasionally become an island in severe flooding. Next, we'll take a look at the climate. 90% of precipitation and runoff occurs between November and April, but annual totals can range significantly from year to year. So this is generally the result of either the southerly migration of the Aleutian lower pressure systems or atmospheric river events. As you can see, typical climatology of droughts and floods, almost every time you have a drought, you're going to need a flood to come out of it. And that's true for most of the places around the U.S. So in California, they have something called FIRO, which is a forecast-informed reservoir operation. And it's a multi-agency study being completed to determine the viability of adjusting water control manuals to improve flood control and water supply operations. So FIRO envisions modern observation and prediction technology that could provide water managers more lead time to selectively retain or release water from the reservoirs based on longer-term forecasts. You may hear that term again as you continue in your studies of water management. So taking a look at some of the flood-prone locations inside the Russian River Valley. So flooding is a big concern, particularly in the Garnerville area, also near Joplin. Flood control releases from Lake Mendocino and Lake Sonoma, they attempt to minimize them to keep those flows, as we discussed, in channel capacity around 8,000 CFS at Joplin and less than 35,000 at Garnerville. So downstream of Laguna, the river is particularly prone to flooding near the resort towns of Rio Nedido, Garnerville, and Duncan Mills. So these are just some of the photos of significantly earlier floods. In February of 2019, an atmospheric river-fueled storm moved into Northern California, and over a 48-hour span, the storm dumped as much as 2 feet of rain in some areas. So as we discussed earlier, it basically turned places like Garnerville into an island, forcing evacuations. So here is a shot of Garnerville before the atmospheric river in 2019, and this was 2 days later. Again, another shot of the Garnerville area. Couple of days before the atmospheric river, 2 days after the atmospheric river. You can see significant flooding. And this is just a general look at the watershed itself. This is the lower end of it. Santa Rosa is just down here. So this is prior to the atmospheric flooding in January 27th of 2019. And here's February 28th. So you can see significant flooding in these areas, especially along this spot here. So what kind of data is available inside the Russian River to help water managers make these decisions, and what data are you going to be utilizing in the rest of the workshops? So there are 27 rain gauges inside the Russian River watershed provided by CDEC. There is very poor radar data because of the orographic terrain there. So you have to rely on a lot of rain gauges to ground truth that. So the rain gauges are 30-minute to 1-hour data. There are 25 stream gauges that give you 15-minute data, and they are USGS gauges. You also get reservoir inflow, outflow, elevation, and storage, as well as Potter Valley releases. That's all 1-hour CDEC data. And then gauge interp and med interp are 2 options that will help you interpolate those gauges for the watershed's precipitation data. So we've given you a little bit of an overview on the Russian River Valley watershed, and hopefully this will galvanize you to go ahead and enjoy the workshops, and it will give you a little bit of a deeper understanding of the watershed that you're working in as you complete these workshops. If you need any additional help, have questions, or would like additional training, you're welcome to go ahead and visit these links here. Thank you very much for your time.